Okay, so I wanted to explore why the formula for the sum of the interior angles of a regular polygon is the same as for an irregular polygon. And if you recall, for the regular polygon, I said, well, the central angle, any polygon can be divided into triangles, and the central angle is going to be 360 degrees regardless of where the center is. Whether it's a regular polygon or an irregular polygon. And so the sum of all the exterior angles is what we're after, so we really want the sum of all of these angles, or in the case for the irregular polygon, the sum of all of these angles. And so we start with the principle that the sum of the angles of any triangle, no matter its shape, the sum of the interior angles of a triangle is always 180 degrees. So really, if we take the number of triangles in any either regular or irregular polygon, and we multiply that by 180 degrees, which is the sum of angles for any triangle, we get the total number. We get the total measure of the sum of all the angles formed. That is, we get, this angle plus that angle plus that angle plus this angle plus this angle plus this angle plus this one plus this one plus this one, right? Plus this one plus this one plus this one, all the way around. It gives us basically 180 times however many triangles there are. We're adding up all these angles, and that's true whether it's a regular polygon or an irregular polygon. But what we're after is the sum of the interior angles of a polygon, which is these outside angles, where we say interior because they're inside of the polygon, but they're along the perimeter here. And so what we need to do is we need to basically take away or subtract all of these central angles. And whether it's irregular or irregular, whether it has 8 sides or 5 sides, it doesn't matter. That central angles, the sum of all the central angles is always going to be 360 degrees. So from the sum of the angles of all the triangles, we just need to subtract 360 degrees, and that actually leaves us with the sum of all of these perimeter angles, if you will. And so if you're taking the sum of all the perimeter angles of the triangles and adding them up is the same as taking all the sum of all of the interior angles of the polygon, these guys. Alright, so that's the sum of all the interior angles of an in-sided polygon. So the number of triangles is going to be equal to the number of sides of the polygon, which would be n. And so the sum of angles of a polygon, whether it's regular or irregular, the sum of the interior angles is always going to be n times 180 minus 360. That's for a regular polygon or irregular polygon. You will sometimes see this as, so this is, again, this is the sum of all interior angles of a polygon, whether regular or irregular. So you'll see this formula as sometimes as 180 n, so the sum of the n-sided polygon, subscript n meaning the number of sides, minus 360. But you also will see this as, if we factor out 180, we can write it as 180 times n minus 2. And that's because if we distribute the 180 we get back to 180n minus 360, which is just this formula. So sometimes you'll see it as the sum of the interior angles of a polygon is 180 times n minus 2, where n is the number of sides of the polygon. Or sometimes you'll see it as 180n minus 360, but these are the same formulas. Alright, that's it, thanks.